hello everyone, welcome back to LeetCode Daily. In this particular video, we are discussing LeetCode Daily problem, maximum number of fish in a grid. And in this problem, we have to given a zero index 2D matrix grid of size m cross n, where row and column represents these conditions. The first is land cell is grid of r comma rc is equal to 0, and the water cell containing any number from a grid like greater than is equal to 0, and a fisher can start at any water cell of r comma c and can be following these operations. And the operation is the fisher is catch any fish from row and column and move their adjacent water cells. And we have to return the maximum number of fish the fisher can be catch if he choose his starting cell optimally, or 0 if no water cell exists. And these are our directions, and r comma c plus 1, c minus 1, r plus 1 comma c, r minus 1 comma c. And so now let's look at their problem statement. Then we have to look their example test cases so that you can understand easily. So here we have to given, in this problem we have to given a water cell which contains number which represent their fish, like any number with greater than is equal to 0 is contain a water cell. And the similar thing is if the cell is equal to 0, then it is a land cell. And so now a fisher can start from, we have to given a fisher can start from water cell and any position. And the second one is it catch all the fish in the current cell where we have to start, like the fisher can start from here, and then we have to move left, right, up and down, and these are our positions. And we have to move to an adjacent water cell like top, bottom, left comma right, and these are our positions. And now let's look at there our goal, what actually we have to return. We have the actual goal is find the maximum number of fish. This fish the fisher can be catch by choosing the best starting cell and collecting fish optimally. Like we have to traverse all these positions, all these grid position, and which one will be give me the maximum number of fish on a grid. We have to return their value, return maximum fish value. So we have to return this one. And now let's look at their constraints so that you can understand how actually this work. So here we have first this one, 1 less than is equal to m comma n less than is equal to 10. So grid size is small, at most we have to traverse 10 into 10, so so that you can trace with brute force or graph traversal algorithm. Like we can use BFS, we can use DFS, and this will be efficient for solving this problem. And this one, 0 less than is equal to grid of ij less than is equal to 10, and this water cell have at most 10 fish, and these 10 fish, this is ensured that operations involving sums remain manageable. And here one thing is we have to add on here, we have to contain fish of grid of ij is greater than 0. This is the condition. And the land cell is grid of ij is equal to 0. So these two conditions you have to take care, like which one is fish condition and which one is land condition. So now let's look at their example first so that you can understand how actually we have to track all these values. And now let's suppose we have to start from this position. So starting from this position, we have there, this is our land cell. So now we have not tracking any other position. So now let's suppose we have to track here. So here we have to go down, right, left, and upward direction is not out of bound here. So the total is 2 plus 1. So the total is 2 plus 1. We have to take this one, and the second one we have to track with, like, this one. Okay, this one is our fish cell. So here we have go down, right, left, and up, so that we have to get 4 plus 1 is equal to 5. And same thing for other any other conditions. Here is land cell, here land cell, land cell, and land cell. And now at this position we have 3 and 4, and the right is this 3 right is our land cell. Here is out of bound, here is land cell. So 3 plus 4 is equal to 7. And so now again we have to check with only 4 and only 1, so that we can also getting a minimum answer, but we have to return their maximum answer. So one thing is here 3 comma 2, this 3 plus 2 is also be 5. So after calculating these things, we have the maximum of answer comma max of face. And so maximum of all these conditions we have to get here 7 is our answer. We have to we have which index we have to take. So starting from, we have to start from 1 comma 3, and 1 comma 3 we have to collect with 3, and collect 3 fish. This 3 we have to collect 3 fish, and we have to move 2 comma 3, this index, and you can say this value 2 comma 3 is our 4. And so the total fish is equal to 4 plus 3 is equal to 7. And now this is the maximum number of fish we have to get here. And now after calculate this one, we have what we have to getting here. Now let's suppose which we have to visited cells we have to track with this star sign. So here we have to track this one and this one. And so the answer is, this is 3, this is 4, so the answer is 3 plus 4 is 7. So you can say we have to get their values optimally, like we have to track two for loops for first is row and second is column, so that we can efficiently get their answer. And we have track all values by using Q, like BFS. And so now let's look at their example 2. So in this example we have to start from this one, and this value we have 1. And now let's look at their right, left, up, and down, these four positions, and you can say these 4 directions. And here 1 plus nothing is here again, and so we have to get 1 answer. And this is the maximum of these one. And here all these are land cell, so we cannot track any other land cells. So now let's move to their last one. So same thing we have to getting here 1 plus 0, you can say, is 1, and the maximum of these two is 1, and the answer is 1. So we have to collect which index. We have to start from 0 comma 0, and you can start from 3 comma 3, and the both cell have at only one fish. So we have to collect one fish and end with their traversal. So now let's look at their coding implementation part, so that you can understand how actually we have to track values. So one second. So this one. and these values. Now first we have their dimensions of their grid, and these are our dimensions n comma m, and then we have their directions 0 comma minus 1 comma 0 1 0. Okay, so these are our directions vector for adjacent cells. And now we have created two variables for first is our answer and the second is our maximum fish, and the answer stores the fish we have to collect it from a connected component, like we have their connected components left, right, up and down, and these are our connected components. And the maximum fish, this maximum fish store the maximum fish collected among all components. Okay, and then we have to use two for loop, these two for loops, and these loops we have iterate through cells, each cell in a grid, and m comma n comma m, and then we have to reset their count of their connected components, and then we have to check with grid of ij not is equal to 0, and if the cell is contained the fish, then we have to track all values, like if not is equal to 0, if 0, then we have their land cell, then we have to directly break and we have to continue, you can say. Okay, and then we have create a queue of pair int comma q, and this one is initialized our queue with their BFS, and this q dot push of I comma j start from BFS from this cell, and you can start from let's suppose 0 comma 0, and then we have to collect, here we have to collect this one, we have to collect fish from this cell, this initial cell, and then we have to mark as visited. We cannot track again and again. If we track again and again, this gives me TLE for unnecessary pre-computation, so that's why we have to mark as visited. And now we have to perform the BFS to explore connected water cells. So this while loop we have to find their connected water cells. So here first we have there a for loop with 4 adjacent directions, so it takes over 4 times, and now this is our logic for, this is our row and this is our column, and after this we have to collect their fish here. 1 second, we have to first we have to check this condition, this is our boundary condition to check their adjacent cell is valid and that contains fish or not. So we have their boundaries, and then this one is answer plus grid of row and column, it collect the fish, and this one adds cell in queue, and this one we have to mark as visited. Okay, and then we have to remove the current cell from a queue, and after that we have to maximum their maximum update their maximum fish we have to collect here, and basically we have to update the fish which we have to collect it from their BFS, and we have also looking here, like we have multiple answers we have to got, then we have to maximum their answer of each one. Okay, so then we have to return their maximum fish. Now I hope you understand how actually we have to performing all operations. First we have two for loops for iterate, and then we have to check their conditions of if they are not land cell, then it is a water cell, and then we have to track with their queue, and you can say BFS, and this BFS we have to iterate through all these positions, and which we have to check with their condition and it is a mark as visited, and then we have to track only 4 position: up, right, sorry, up, right, left and down. And then we have to track with their row and column form. This is our row and this is our column, and now then we have to find their maximum. So now let's look at their time complexity. So the time complexity of this code is, first we have to perform their BFS. This BFS perform for each water cell, and each water cell we have to visit it once, and so that like we have to use these for loops. Okay, and this one is 4 time, and so you can say your time complexity of this code is O of m into n plus 4. So this is constant, so we can remove and discard, and so the total time complexity of this code is O of m into n, and the space complexity of this code is we have to use BFS and a queue which store all the cells, and so the space complexity of this code is O of m into n. And in the worst case, if all cell are water cell, then this space complexity is reduced. And so I hope you understand the logic behind this problem and the implementation part, how we achieve all these position, and then we have to update their maximum phase position. And now you have also understand how actually we have to track with all the positions which are present on their grid. So thank you everyone, thank you so much.